See, in the last lecture, we have seen the technique of regression. We have considered the lines of regression. So, what we did actually is we have considered the data, and then we try to analyze the data. We try to fit the lines of regression, and then while fitting these lines of regression, we try to see that what was the correlation coefficient, means up to what extent we have the confidence that this line is good fit. Okay, so now sometimes it happens that the line is versus that will be a rough idea. Okay, so I will be not good confidence. Okay, I will not be in good confidence to say that yes, this is a better line. Okay, and hence the baseline exists. Okay, and by using the technique of least squares, okay, so we are able to find the baseline. Okay, and hence now in this lecture we are going to change the technique of finding the line. Okay, so here up to it we have used the regression analysis. So we are going to use now the method of least squares. Okay, so here what we are going to do is we are going to use the method of least squares. Okay, and then using this method of least square, we are trying to find the line. Okay, so let us try to find the lines again. So here we have to consider the technique, the next topic, that is curve fitting. We say fitting of curves. So here we are changing the technique. So in the previous chapter, we have seen the regression analysis. So regression, we have linear regression. So we have seen only the linear regression. We have seen only the line. Now we'll go for the non-linear also. So we'll go with one linear, that is the line, and the another non-linear. So non-linear, you can have the curves second degree onwards. Okay. So first we will consider first degree curve, or it is also called as straight line. Okay. Or this is called as first degree curve. Okay, so here, as I said, we are going to change the technique. So what technique we are going to use is we are going to use the method of least squares. Okay, so what we have here, let y is equal to ax plus b. This is equation 1. B, the first degree curve, or it is also called as straight line. Okay, so if I use the method of least square to this curve, okay, so here what we have, this y is known, this x is known. So we have so many values of y and so many values of x here, and then we want to fit this line to the curve. Okay, so now here x and y are knowns. Okay, so what values I need to find? What are the unknowns in this equation 1? What are the unknowns in this equation 1? Yeah, here the unknowns are A and B, because X data is given to you, Y data is given to you. So this is what we need to understand properly. What is given and what I want to find. Okay, so in this equation, X and Y are not unknown. Commonly they are unknowns. Okay, but here in our case, X and Y are the data sets which are known to us. So what is not known to us is the constants A and B. So now for us, X and Y become constant and A and B become variable. Okay, so we have to find the values of A and B. Now the question is, you have seen matrices in the same one. Okay, you have solved the simultaneous equation using the matrices. Okay, and now if I want to find out two variables, how many equations I need to solve. Okay, so how many minimum number of the simultaneous equation is needed to find the value of two variables. Okay, okay, that's great. You got it. Okay, good. So we need two equations. Okay, and hence now if I want to find out the value of A and B, I need to have two equations. Okay, so this method of least squares will give me two equations. So now, how to generate these two equations from this x data and y data? X is a data set, y is a data set, x is a data set. Now, the question is that I have to consider all the points, and we know there are more than 2 points in x data set and y data set. So, if I will have just 2 points, then it will be easy for us that only two equations and solve these two equations. But what we have more than 2 points, and the most important thing is we have to consider all the points. So here we can say the normal equations are given as. So these normal equations that I am writing are obtained using the method of least squares. Again, so I'll be having here, I want to have all the points. I have to consider all the points, and hence consider this is summation y is equal to a summation x. Okay, so I am considering the sum over this. So sum on this y is equal to ax plus b. So what this will be, summation y. Summation is a linear operator. So a summation x plus summation b. And moreover, what we have here, this summation, as we are considering all the points. So all the points means I is running from 1 to n. So I is running from 1 to n, and hence I is running from 1 to n. So what will be the summation? I running from 1 to n summation b. So I can write this as, okay, so b plus b plus b plus b, so on the term plus b, this will be n times. And so this will be n times b, easy. Okay, so that's why this next term what I'll get will be n times b, and this term is plus n times b. And then again I want the next equation. Okay, because one equation I can get using the summation or taking the sum of this equation. Now I want to obtain the next equation. So what I have to do is to obtain the next equation, multiply equation 1 by x. So what I'll be having is xy is equal to x square plus bx. So multiply equation y by x, and you will get this. And now take the summation. So here you will be having summation xy is equal to a summation x square plus b summation x. Okay, so that's what I'll be having. Now this is my equation 2. So these are the normal equations. Okay, and here what we know is where n is equal to number of observations. So here n is equal to number of. Okay, so that's what we have. So this is the curve that we want to fit, and these are the normal curve corresponding to this equation. Okay, now we have considered the straight line, the first degree curve, and now I want to consider non-linear regression. So in non-linear, I consider the second degree curve. So we have second degree curve. Okay, so you have already studied this second degree curve. Okay, so I want you to give me the name of this second degree curve. Okay, so what is the general or what is the second degree curve you have studied? What what are the second degree curves you have studied? Y is equal to ax square parabola. Okay, again, what are the next second degree curves that you have studied? You have studied some more second degree curves, no? Circle, correct. Again, another name, ellipse, good. Again, the curve which comes into a pair of branches. What is the name of that curve? Hyperbola, correct. That's good. Okay, so these are all the rectangular hyperbola is also second degree curve. Good, Bhavesh. Okay, so these are all the second degree curves, and what we are going to study is actually a parabola. So parabola you have studied, but here the standard parabola you have studied, but here we have a general parabola. Okay, and then we'll see how to write a general parabola. Okay, so we have here the name of this curve is parabola. Okay, so we have let the general parabola y is equal to ax square plus bx plus c is going to be 1. B, the second degree curve is going to be parabola. Okay. Then what we'll be having now, this is the second degree curve. So what we have here, we have x and y are known. Okay, so x and y is known, so that means x square is also known. So if I know x, then I know x square. Okay, now what are the unknowns in this case? Yeah. What about the others? Others are getting or not? Okay, that's good. Okay, so the unknowns are A, B, and C. Then again, we have to go to back our matrix theory and simultaneous equation. How many equations? How many minimum number of equations you need to get the value of these three variables? Yeah. So what we know is to have a unique solution, we must have rank is equal to n. Okay. So rho is equal to n. So rank is equal to the number of variables. And here we know the number of variables is going to be 3. So that's why the rank must be 3. So that means there must be 3 non-zero rows. And if there are 3 non-zero rows, that means there are 3 equations at least we need, which are linearly independent. And then if we have 3 linearly independent equations, then we are able to get a unique solution. So here, my task is to find the 3 linearly independent equations. And so the normal equations we have to find. So the normal equation for this parabola are given as, okay, hence normal equations are given as. So what are the normal equations I'll be having? First, take the sum as it is. So what will be having? Summation y, a summation x square, b summation x plus nc. Okay, so where n is going to be the number of number of observations we have. Then multiply this equation by x and have the sum. So I'll be having x y, a summation x cube, b summation x square, c summation x. Then again multiply this by x square and have the summation. So summation x square y, a summation x raised to 4, b summation x cube, c summation x square. Okay, and this equation 2. So these are the normal equations we can have where see, I know x and I know y, that means I know all the terms except this n. So where n is equal to number of observations. And now I know all these terms. Okay, so this is what we have. Okay, now we can see the first degree curve and the second degree curve and the corresponding normal equations. So normal equations you have to write using the curve that you want to find. Okay, remember this. If this is the curve, these are the normal equations. Okay, and now if I have this normal equation, so I need to know what I want to find out is x is given to me, y is given to me. So I have to find summation x, I have to find summation y, I have to find summation x into y, and then I have to find summation x square in case of first degree curve. And if it is a second degree curve, then what I need to know is summation y, summation x square, summation x, then summation x cube. X square already we have considered. Summation x cube, summation xy, summation x square y, and summation x raised to 4. X cube is already calculated. So these are the terms which we want to calculate, and hence we consider the table and calculate these values. Okay, so uh, I hope these equations are you are able to understand these equations. So is there any doubt in these equations? Have you got the equations? Is there any doubt? No doubt. That's very good. Okay, so if you have no doubt in this equation, then we'll try to solve the problem. Okay, so let us try to see the problem. So here, what we are doing actually, so mathematically we are building the curve, but actually we are building the model. Okay, and these are the regression models we are building for data analysis. Okay, so we need to understand these are not just the lines, or this is not just a second degree curve. These are actually model we are fitting to the situation. Okay, we are finding the regression models. So as in the previous example of regression, I told you that the model which is used for data cleaning. So if you have any figure which is missing and which is within the range, then it is called as data cleaning. If I want to find any figure which is not in the range of data, which is out of the data range, is called as predictive model. Okay, so predictive data analysis. Okay, so for example, I want to predict what will be my sales, or what will be my production, or what will be my profit after a few days, few months, or few years. Then that is called predictive analysis, and for that we use the predictive model. Okay, so here we are building actually the models for data analysis. Okay, so mathematically we are fitting the curve. Technically we are building the models for the data analysis. Okay, so let us try to build a linear model first. Then we'll go for non-linear models. Okay, so here we'll go with the first example. Okay, so we just have to fit a straight line to this. Okay, now we go with the solution. So we can have, this is example one. Okay, so we go with the solution. We'll have let, what I want to find is a straight line. Okay, so let y is equal to ax plus b. Okay, give this equation so that we will able to refer it later on. Okay, b, the straight line. So as the question is asked, we have to write the answer. B, the straight line. Okay, so if this is a straight line, we must write the normal equation. So the normal equations are given as. So what are the normal equations for the straight line? So we have summation y. So you don't have to by heart. Okay, take the summation. So we'll be having a summation x plus nb. Multiply this by x and take the summation. So summation xy, a summation x square plus b summation x. So this is equation 2. Okay, and here what we have. So here n is equal to number of observations. So what is the value of n here? So here n is equal to, see what is the length of the data set given to you. So it is going to be 6. So here we have n is equal to 6. Okay, now once we know, now what I want to find out is I want to find out summation x, summation y, summation xy, and summation x square. So let us try that. Then what we can do is consider the following table. Okay. So what is the table we want to have? See here, we will need this x, y is given to you, x into y and x square. Okay, so these are the columns needed, and what we have to do is we have to find a summation. So we are interested in summation. So what is summation x, summation y, summation x, y, and summation x square. Okay, so here uh, I'll try to find this one. Okay, so I hope you are making table with me. Is how this table. Okay, we are interested in summation of this. Okay, so what are the observations given? 3 to 8. Okay, so that's going to be 3, 4, 5, 6, 7, 8, and this is summation 33. Okay, so what we have here, 8, 6, 5. So 8, 6, 5, 7, 6, 4, and summation is 36. So I want you to calculate this summation. Okay, so please calculate this summation and let us check. Okay, so please check the observations properly so that you will not miss any entry. Okay, so I want you to calculate these two entries and give me. So please calculate these two entries. I'll also calculate with you. Okay, so I'm also calculating with you. So please have this entries here. So I hope you have calculated the table. Okay. So let us check your calculations with my calculation. So I hope you are calculating. You are done. Are you done with your calculations? Okay, good. Okay, so let the other who complete calculations. Uh, what are the values you have got here? Okay, yeah. So you got the values. So check your calculations with me. I hope your calculation is correct. Okay. So you can see your calculations. These are the calculations you must get. So I hope all of you are getting this one. Are you getting the same calculations? Yeah. What about Aniket Davi? Are you getting the calculations? Good. Anup Kulkarni? Yeah. Okay, that's good. So you are getting the calculations. So once we get this calculation, then what we have to do is we have to use the normal equation. So here we need these values in normal equation. So what you have got here, see, this last is the summation. So this is summation x, this is summation y, this is summation x into y, this is summation x square. Okay, so we got all these values, and hence we can put these values in equation 2. So what we can write is, we can write here from equation 2, again, the normal equations are, okay, so I'm writing this as, see, we want to find this A and B. So I'm writing this side on the right hand side on the left and left hand side on the right. Okay. So I want summation A. So this is going to be 33 times A plus 6 times B is equal to 36. Okay. And what we have next? A summation x square. So 199 times A plus 33 times B, and this is equal to 189. Okay. So once you are able to write the equation properly, definitely you are able to solve this. So we can write directly. Okay. Solving above equations. Okay. So if we solve this equation, what we'll get is, we get A is equal to, and we have the value of B is equal to. So I want you to calculate the value of A and B. So what is the value of A you are getting? A is going to be minus 5142. What about the others? Because you need to verify and cross check this value whether you are getting correct or not. Okay, so please let me know if you are getting the same value. Okay, Nishika got the value. Uh, is going to be same. What about others? Yeah. So you got the value. Yeah. Badransh also got, Kalyan also got the same. Okay, good. Okay, so you got the value of A is going to be minus 0.5142, and this is 8.82. What is the value you got here? So it's going to be 8.8285. Okay, 8285. Okay. So here we got the values of A and B, which is our task. And once you get the value of A and B, what we are finding, actually, we are finding a straight line. So we are putting a straight line. Okay. So let us write this straight line. So from equation 1, I can put the value A here and I can put the value B here. And we are able to write the equation of the line. So we have from equation 1. Okay. We have. So what we'll be having here? Y is equal to minus 0.5142 times x plus 8.8285. Okay, so this is the required straight line. So is the, okay, so this was required straight line. Okay, so that's how we are able to get it. Okay, so do you have any problem in this question, or do you have any doubt in this question? If you have any doubt, you can ask, please. Okay, good. So that's great. Let us have the another question there. Okay, so I have the another question. Okay. So now, as I told you that we are fitting, or we are finding the we are doing the data analysis. We are finding whether there is a linear relation between these two or not. Okay. Now we have the another example. So what this example is in a study between the amount of rainfall. Okay. So the amount of rainfall at a particular place is measured. Okay. And this may be, see how we measure the rainfall. We measure in millimeter, centimeter, inches, like that. Okay. So suppose this is in centimeter. Okay. This amount of rainfall in centimeter, and then uh, the quantity of air pollution removed. Okay, so please be careful. This what we have is the quantity of air pollution removed. Okay, so how much air pollution is removed by this rainfall? Okay, so the question is this air pollution, the quantity of air pollution is removed. Okay, so if you remember recently that in Delhi we have a lot of air pollution, and then for that water cannons were used so that the cannon throws the water droplets, and these droplets they catch the air pollutants, okay, and then get them down on the earth. Okay, so that's how the air pollution, the quantity of air pollution is removed by the rainfall or the water droplets. Okay, and now this is the study. Okay, that how much it was removed. Okay, so if you know, or if you have visited the PUC center, the pollution under control, that every vehicle has to take the PUC certificate. For four wheelers, it is for a year, and for two wheelers, it is for 6 months. Okay, so if you have visited that, the measure of this quantity or the unit of this quantity is ppm. Okay, so it is parts per million. Okay, and now that's why suppose this measure is in ppm. Okay, so we have this quantity removed in ppm. Okay, parts per million. This quantity was removed. Okay, and now the question is there any relation or is there any linear relation? Okay, so that's what we have to study. Yeah, so this is what the problem we have, and then we have to justify our answer by the mathematical calculations. Okay, and we'll see what we are able to get out of this. Okay, so let us see here. Yeah, let us try to fit the line to this data, and then we'll see what conclusion we get. Okay, after this studies. Okay, so we'll try to solve this problem. Okay, so what we have here, let y is equal to ax plus b is equation 1. B, the straight line. Or what are we having? The amount of rainfall. X and the quantity of air pollution. Pollution y removed. Yeah. And now once we have decided this is going to be line, so we are able to write the normal equations. Yeah. So let us write the normal equation. So we can have the normal equations are given as. So what are the normal equations you'll be having? Summation y, a summation x plus b, and here you'll be having summation 1. That means it is going to be n b. Okay, then multiply this equation by x and how the sum. So you'll be having xy a summation x square b summation x. So this is equation 2, which are the normal equations. Okay, and where what we know is a xy is known, so n. So where n is equal to number of observations. So for this problem, n is equal to, see how many observations we have. So here we have 8 observations. Okay. Now, hence, what we can do is the next step is consider the following table. Okay. So, what is the table we want here? See, for the line, we want the same x, y, x into y, and x squared. Now, I want you to calculate this table and give me what the summations are. So, we are interested in summation. So, please calculate this table and have the summation. So, we can put the values in the normal equation and then we'll able to solve this normal equation so that we can have the relation. So please make the table and give me what the table you are getting. I hope you are calculating the table with me. I'm also calculating this. I hope you have calculated the table and ready with the table. Many of you got ready with the table. You can check your table. So I hope you are ready with your table. So please check your calculations. So you got it. Okay, that's great. So let's check your calculation. Okay, so are you getting these calculations? So this is going to be x, this is going to be y, this is x into y, and this is x square. Okay, so how many of you are getting the same calculations? All of you are getting the same calculations. That's good. Okay, so that means your calculations are correct. Okay, great, good one. So now once you got this calculation, so what do you have? This is the summation. Okay, so this is summation, summation x, summation y, summation xy. Okay, so this is summation y, and this is a summation x square. So once you know this whole summation, you are able to write the normal equation. So you can write from the equation 2. Okay, so we have from equation 2. From equation 2, normal equations are given as. So you'll be having a times summation x, so 29.5 times a plus n times b is equal to summation y, so 90.6. Then we have x square, so you'll be having 121. This is we need to take this here. So please have the correct value. Okay. I hope you have got correct values. Okay, so it is going to be 325.72. Okay, and then 121.01. So this is A plus you got summation. This is a x square b summation x. So it is 29.5 b, and this is what you'll be having 325 point. Okay, so you got here 72. Okay, so this is 7. So can I have here this is 320.72 and this is 0.01. Okay, so these are the correct values. So you got this one, and now what we have to do is solving this above equation. So we can have solving above equations. We have, so we have a is equal to and b is equal to. So tell me what are the values of a and b. So yeah, you should not get two different values. You are getting Kalyani, you are getting 0.3101. So then we need to be careful. What are the correct values? Anushka is getting something different. So please give me the correct value. Adesh is also getting something different. So please find the correct value. What are the correct values we are getting? So you all are getting different values. So that should not be the case. You all of you must get the same values. So please, one thing you need to be careful that you have to enter these values properly. So as I have corrected this, it will be 121.01 and this will be 325.72. Okay, this is n. So we don't have any problem with this, and n will be always integer. So using these values, you have to get correct values. Okay, so I want you to get the correct values. So correct values, all of you are getting now. Yeah, with the sign, Kalyani, we have to get a sign also. We cannot miss the sign. So it is going to be minus 6842, and we accept of 42 or 25. Okay, so A is going to be minus 0.6842. So here we are getting A is equal to minus 0.6642 and B is equal to 13 point, okay, what do you got here? 8481. Okay, so 13.8481. So these are the values that we accept. Okay, and now once you get this value, so what you have to do is you have to write the line of straight line that we want to fit. So we can say from equation 1 we have, so what do we have? Y is equal to minus 0.6642 x plus 13.8481. Okay, so that is what the line we have, or this is the linear model for the situation. So is the required straight line. Okay, however, you can see the relation between this x is a rainfall and y is a amount of air pollution removed. Okay, so that's what we have, and we can see the slope is going to be negative. Okay, so the confidence we have negative. Why? Because we cannot guarantee that there will be more rainfall and more quantity will be removed. Okay, so here we can see what is happening if there is a less rainfall, actually more quantity is removed, and if there is a more rainfall, the less quantity is removed. So you can see here 5.1 centimeter. If there is a rainfall of 5.1 centimeter, then it is going to be 10.4 ppm air pollution is removed. Whereas if there is only 1.1 centimeter of rainfall, there is 13.1 ppm air pollution is removed. So you can have just guess that these are inversely proportional. Okay, so you can say if there is a less rainfall, more quantity of the air pollution removed. Okay, but can we say that this is true? So can I say that if there is a less rainfall, more air pollution will be removed? Is it a correct statement? So we have a data. From the data we have fit the model, and we got the situation, and we got to know that this says that the data says that if there is a less rainfall, more quantity of the air pollution will be removed. Is it true? Think over it and then tell me what it says. So is it true? Is that true that the less rainfall will remove more quantity of air pollution? If it happens, what will happen on the dry day? So that means there is no rainfall, all the air quality, air pollution will be removed. No, this will not be the situation, and that's why the data that what we have opted and the equation what we have opted, that is not a good fit. Okay, but that means there are the another factors which are responsible for the removal of this air pollution also, and that's why only this one quantity cannot justify the removal of air pollution. So we need to consider multivariate regression. Okay, so this is just a one variate regression, and hence we have to go for the multivariate regression that you will see in the another subject. Okay, so that's what we have. Okay,